Hello, let's continue our Sudoku adventure with Hipgerbil Poemgulp by Gene. No idea what that is or if I pronounced it right, but that's the title. So let's go over the rules. I don't think we've had this rule in adventure yet. I want to say, at least the first time I saw it was a Glum Hippo puzzle, and he may have invented it, but don't quote me on that. Anyway, so we do have normal 6x6 Sudoku rules. So in each row, each column, in each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have XY differences. That's these diamonds in the grid. I'm going to go over this rule carefully. Digits horizontally separated by a diamond have a difference equal to the leftmost digit in the row. So let's say the leftmost digit in the row happens to be a 2. Then that means the difference between these two is 2. So they could be, for example, 5, 3, or even 3, 5. We don't care about the order. Just the bigger minus the smaller, whatever that ends up being, that's the digit that's placed on the very left. Vertical works similarly. So let's just take these two here. So let's say there was a 3 up here, because the difference is equal to the topmost difference. So if the topmost digit is a 3, then the difference between these two is also 3, and we could do, say, 5, 2, or 5, 2 this way, right? Take the bigger minus the smaller, and that's the digit that goes in the top. All right, and all diamonds are given. So if this is a 3, and this was 5, 2, there should have been a diamond there, and there's not. That is not okay. In the solution, all of our diamonds are given, and that's probably going to be important for the solve, so remember that. This would not be allowed. If this was a 3, this 5, 2 would not be allowed because there's not a diamond there. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I think these chains are always a good place to start. So we need to be able to like continuously add the same digit twice. So if I started with 1 here, I could obviously do 2, 3. So I could have a difference of 1. I could do 3, 5 and have a difference of 2. But I can't have a difference of 3 because if I did 1, 4, I'd have to then go to 7. So that means that this digit here, which represents that difference, is only a 1 or a 2. And this is also a 1 or a 2, giving us a 1, 2 pair. Now, the other thing to talk about is any row with a diamond cannot have a 6 as its difference, right? 2 digits can't have a 6 difference because we're 1 through 6. The biggest difference is 5. So this cell can't be 6. This cell can't be 6. This cell can't be 6. Whoopsie. But we could put a 6 in any of these. Could put a 6 in any of these 3. Let's look at the top row. This can't be 6. This can't be 6. Can't be 6. Can't be 6. So we know that 6 is in one of these 2 cells. Now, it's interesting if this was a 6, because 6 with 2 would put a 4 here, and 6 with 1 would put a 5 here. But I don't really have a problem with that. So we can't like rule out 6 from there. All right, so let's think about, I don't know, should we think about what's possible here? If this was a 1, these would be basically they'd just be consecutive digits. If there was so if this was a 2, one of these is a 2. Let's think about that. One of these is a 2. And if we're a 2, I think we have to do 1, 3, 5 because 2, 4, 6 isn't possible because the 2's up there already. So we're going to be 1, 3, 5. So if this was a 2, we'd be 1, 3 pair surrounded by a 5. And if this was a 2, and this is temp markings, this would be a 1, 3 pair with surrounding a 5. Oh, sorry, that's completely wrong. Sorry. We'd be either 1, 3, 5 or 1, 3, 5. Sorry, they'd be a 1, 5 pair surrounded by. Sorry if that was confusing because that was wrong. It'd be a 1, 5 pair surrounded by a 3. I'm trying to see if there's anything that we can say about that. That means one of these 2 cells is a 3. At least one of these 2 cells is a 3. So that's going to eliminate 3 from here and here. Basically, there is a 3 up here and there is a 3 down here. That's something we can conclude. Anything about the 1, 5 pairs that I conclude? Not really. They don't line up or anything. Okay. Consecutive has a lot more open. It could be 2, 3, 4, 3, 4, 5, 4, 5, 6. Okay, so the top row 6 is one of these 2. Make sure I did that right. This left row 6 is here, here, or here. So we can't really use that, can we? All right, how about this row, which has 2 differences that don't chain? We know that either this is a 3 or this is a 1, 5. I don't know if that's interesting or not. But if we need two different differences, I mean, we need the same difference from two pairs of digits. I think we're limited on how big that can get, right? It certainly can't be a 5. So 1 is possible, 2 is definitely possible. We could be like 1, 3, and 4, 6. 3, we could do 1, 4, and 2, 5. 4 would be 1, 5, and 2, 6. Oh, that's possible too. 4 would be 1, 5 with 2. Do I have to account for the fact that either one of these is a 3 or a 1, 5? I don't know how to really account for that. That feels like a lot to account for. Okay, 1, 2, 3, 4. These have a difference of at least 3 because the 1, 2 pair has removed bigger differences or smaller differences. Huh. So this has a difference of at least 3 from 1, 2, 3, 4, which means with the 1, we could be 4, 5, 6. With the 2, we'd only be 5, 6. With the 3, we'd only be 6. With the 4, we could be a 1. Kind of like a German whisper. In fact, it is a German whisper. It's at least 3 different. There aren't any other... We don't have any other vertical... This vertical, basically there's a German whisper here. I don't know what to do with all this information. I'm clearly missing something important. 6 is down here somewhere. We know the 6 isn't here because of the diamond. All diamonds are given. I wonder if that's important. So we got some empty rows. I don't think it's that hard to avoid differences. I don't think there's like, oh, you can't avoid having a difference of 1 or anything like that. That's certainly not true. Well, we know that these 2 digits are not a 2. Why do I say that? Well, imagine if this was a 2. This would be 1, and then now there's a difference of 1 in this column, and then they should have been there should have been a diamond there. So this can't be 2, and this can't be 2. Along with all these digits can't be 2. They also, I think they could be 1. I don't know what to do with that information. These are not 2. Oh no, I'm not sure what to do with this puzzle. This is a chain, but this difference is different than this difference probably. Is that a problem with like? So imagine this was the 1, 5 pair with the 3 in the middle. The 1 would prevent there from. So I don't know. The 1 would prevent a difference of 1. So it would be 5. It would be 1, 3, 4, or 5. Wouldn't be 1, 3. So it would be 1, 4 or 1, 5. If this was a 5, I mean, this doesn't seem to break anything. I'm going to look at this again, see if this breaks anything. That would be a 2, 1, 5, 3. So what's left? Maybe that's important. What's left? So if this was the 2, 1, 5, 3, the 2 digits that aren't accounted for are 4 and 6. So we need a 4, 6 pair here, or we need a 4, 6 pair here. Ooh, that's it. That's the problem. Wow, that's a tough spot. So let's imagine again that this was a 1, 5 pair and this was a 3. So let's imagine again that this was a 2. That forces us to go 1, 3, 5 in some direction. So this is a 1, 5 pair and that's a 3. And so now down here, the 2 digits left are 4, 6. And guess what difference they have? They have a difference of 2. So there ought to be a diamond there, and there's not. So this cannot be the 2. This has to be the 1, making this the 2. And then now this is a 1, 5 pair with a 3 in the middle. Okay. And this is a 4, 6 pair. All right. That feels like progress. So whatever this digit is, this is 1 smaller than it. So this can't be a 3, because if this was a 3, that would have a difference of 2, right? So this is 4, 5, or 6, which makes this a 3, 4, or 5. These are consecutive digits. 3, 4, 4, 5, 5, 6. I don't know what to do with that information right now. Since this is a 1, this can't be 2. So this is 3, 4, 5, and it can't be 6 because 6 is up here. So from the 3, we'd have to go 4, 5. From the 4, we could go 5, 6, or we could go 4, 3, 2. And then from the 5, we'd have to go 4, 3. But it can't, okay, this can't be a 5, because we can't go 6, 7. We can't go 4, 3. So that's not a 5. So 3, 4, 5, or 4, 5, 6, or 4, 3, 2. Huh. Two here is a little bit interesting because it forces this to be a 4 and that to be a 6. Why do I say that? I mean, I'm looking to see what I can do with this puzzle. I'm sorry if I'm missing something obvious, but let's say this was a 2. Then this can't be a 2 because it's a 2 in the row. And this can't be a 1 because what would have a 1 difference with 2? Well, only 1 or 3 and they'd both be gone. This would be a 1, this would be a 3. So actually we could only be a 4 and the only 4 difference from 2 is 6. So if this is a 2, that's a 4 and that's a 6. It has consequences for sure. I don't know if it breaks the puzzle. Is there any digit we haven't accounted for? 1, 2, 3, 4, 5, 6. No, there's not. These cannot be consecutive, though. Do we have to worry about... Maybe that's a worry, actually, still. So 3, 2... So if this was 4, 3, 2, then this would be a 5, 6 pair, because we can't leave 5, 6 behind down here, though, because they would need a diamond. So we can't actually do 4, 3, 2. We have to go 4, 5, 6. 4, 5, 6 has a problem that it leaves 2, 3 behind. We can't leave behind 2 consecutive digits. So we have to leave behind the 2 and the 6. That's the only option, which then makes us a 5, 4, 3. Okay. Had to keep thinking about this column. This column is actually really interestingly restricted. This was always going to be what it was, I think. Maybe with the 3, 5 swapped is also possible. I'm sure it is. Okay, from 5, a difference of 1, I don't know, am I really doing this? A difference of 1 would require a 6. A difference of 2 would require it to be 4, which it can't be, so this can't be a difference of 2. And a difference of 4 would require it to be a 1. So there's definitely a 1 in one of these two. These can't be 1. Oh, but we also have this difference here. We can't have a difference of 4 from this 3 across here. Now that it's a 3, there is no difference of 4. 7 or -1. So this has to be a 1, which then means this is a 2 or a 4, and this is a 6. Okay. That 1 makes this a 5, and that a 1. All right, making progress. So this top digit here is also a difference between these two. Oh, wait. I got rid of this 6, so that's a 6. The difference is 5, and so this is a 6 as well. And that makes that 4 and 6. Nice, that's 2 and 6. Oh, we're making good progress now. This is a 2, 4 pair. Ah, the 4 gives us the answer. That's 2, that's 4. So these two digits are a 2, 6 pair. We know the order. That's 2, that's 6. And these are a 1, 3 pair. What did I just do? There's a 1, 3 pair. We don't know the order yet. Whoa. What are the two digits left here? We have 1, 2, 5, 6. We need 3, 4. Ah, so that's 3, that's 4. So these have a difference of 3. What are the 3 digits left? It'll probably make it easier. 1, 2, and 5. Ah, that's a 5. That's a 2. Easy. That's 1. What are the differences left here? Also 3, 4. Ah, so that's a 4. That's a 3. So this has to be a 5 to have a difference of 4. We DT doot in the corner, by the way. Well, that's a 2. All right, and now we're finishing up. So up here we need a 3, 4. That's 3, that's 4. That's 1, that's 3. And down here we need a 1, 1, 5. So that's 1, that's 5. All right, I'm not going to go through every domino and make sure we don't have those differences, but I will trust Gene's construction here. Cool. Really interesting puzzle. This column was key, and I had to just keep looking at it. Like, I couldn't stop looking at this column. I had to find like 3 or 4 deductions from it before we were finally done with it. And by that time, we finished the puzzle. So really neat construction of, it seems like a unique to 6x6 restriction with this particular formation of XY differences. So that's a really neat discovery, Gene. So yeah, I definitely enjoyed that. Let me know how you did. And if you enjoyed it, why not leave a like, subscribe, and a kind comment below. Thank you.